So I just stumbled upon nvmath-python, and it's like NVIDIA is bridging the gap between their powerful math libraries and Python. How cool is that?
Wait, what? NVIDIA's math libraries are typically for C++ or CUDA. How are they making this work in Python?
Exactly. They've created intuitive APIs so Python users can access all those features without needing to dive into C. It's like giving Python a turbo boost.
That's interesting. But doesn't that assume users have a solid grasp of how NVIDIA's libraries actually work?
Good point, but I think by making it accessible, they're lowering the barrier for entry. Plus, it integrates with arrays and tensors we already use.
Right? They even utilize libraries like CuPy and PyTorch, which is super convenient. But how effective is it really?
I mean, the examples in the documentation show some powerful capabilities, like matrix multiplications with fine-tuned options.
Hold on, fine-tuning. You mean users can select specific compute types like mixed precision? That's impressive.
Yes, it's like they're giving developers the tools to optimize their operations on the fly. That must save a lot of time.
But what about performance? I assume there's some overhead when using these Python wrappers compared to native C implementations.
Absolutely, there's likely some trade-off, but they mention it's designed to minimize that by running on NVIDIA's device-side APIs.
So they're leveraging GPU capabilities directly from Python. That's a game changer for speed.
Totally, imagine you could call cuFFT right from a NumPy function. It's revolutionizing how we handle computations.
Right, but I wonder, how does this affect debugging? Python users are used to a different kind of error handling.
Great question. It could get tricky since GPU errors may not always surface like they do in Python. Users might need to adapt.
That's true. And speaking of adaptability, did you see that they allow custom prologues and epilogues for FFT functions?
Yes, that's such a cool feature. You can define behavior like unitary scaling right in your Python code.
But I'm curious if this added complexity might deter some users. Isn't it a lot to manage?
Definitely a balancing act, but for those who need performance, it could be worth the effort. It's all about the use case.
True, and if it's in beta, it's likely they'll continue to refine it based on user feedback.
Exactly, plus, being in beta means users can influence its development. It's like being part of the process.
That's an enticing offer for developers. But do we know if they're planning to expand the library?
Not much info yet, but given NVIDIA's focus on AI and ML, they might add more features tailored to those areas.
Yeah, that would make sense. Just think of the applications in data science and machine learning.
And don't forget about gaming. Could you imagine utilizing this for real-time physics calculations?
Mind-blowing. But aren't we also considering the limitations of running intensive tasks in Python?
True, Python's not as performant as C, but for many developers, the trade-offs might be worth it for ease of use.
Right? It's all about striking that balance between performance and flexibility. But I still wonder about the long-term implications.
Like whether these libraries could eventually shift how we think about Python's role in high-performance computing.
Exactly. If NVIDIA keeps pushing these boundaries, Python could become even more central in those fields.
And that could change the landscape of both academic research and industry applications. Exciting stuff.
For sure, but wait, do you think we might be overselling it? There are still challenges to address.
Yeah, I mean, being beta means there'll be bugs and limitations. Users need to weigh the pros and cons.
Absolutely, and while it's promising, not every developer will want to dive into that complexity.
So it's a fascinating development, but maybe with a healthy dose of caution.
Exactly, it's like stepping into uncharted waters. There's potential, but the risks are real.
And that's what makes it such an intriguing conversation. I'm curious to see where this goes.
Same here. It'll be interesting to watch how the community responds and shapes its future.
Totally, so what's our takeaway? Is NVMath-Python a game changer or just a beta experiment?
Maybe it's both. It sparks innovation, but it requires careful navigation from users.
Agreed, and it's a reminder that with great tools comes great responsibility and learning.
Well said. Let's keep an eye on it and see how it evolves in the coming months.
Definitely, and who knows, we might be talking about it again soon with even more insights.